you were told that these two lines are parallel, right? You were given this angle, let's call it A. You were given this angle, let's call it B. You don't need to use the silence at all. Silence was meant for the last question. So this is angle B. Obviously extend, yes, Rob?
Can't you prove the angles are the same?
Yeah, that's what I'm doing.
Oh, okay.
If I extend this line, so that now basically it looks like this. So these are parallel. If I extend this line, so it's like this. So basically it looks something like this. This is angle B over here, right? Yes?
Mm-hmm.
Well, what's this angle over here then?
Equals angle B.
Yeah, and that was the first question, right? This angle was the same as this angle by translation, and this was angle B. Well, this is angle B right here. This is the same as B over here, and just translated it back. So that's angle B. This is the same as angle A, because they're opposite angles. Finally, this last one, this is 180 minus A minus B. And these two angles are the same as well. So they're two similar triangles because all the angles are the same. Then now you can assume that the sides are proportional, which is how you answer number B. Okay? Back to what the best thing I can try to explain to you, Cecina, is that do you know all the calculations that you use for A? Notice how you use them for B? So you're using B assuming that A was true. Right? You can't make that assumption. So you're assuming B was true already, and that's how you calculate A. I promise I'll try to find out a better analogy of you can't use your assumptions to prove what you're assuming. But that's how you solve that one for the similar triangles. Basically, all the angles were the same, and that's why they're similar. Okay. Any other questions regarding the test? So the sum up on Wednesday will be basically nothing on the first page because that's sort of a review, but we're going to talk about equivalent triangles and tan ratio, and add to that sine and cosine, and what we're doing today is covering application problems. Yes.
Basically what I did when I got home.
Sorry?
That's what I did. I put
You get 2.5.
yeah, but I put
Really explain. We'll talk about later. I want to talk about your test in front of everyone. Anything else? Mo, you said a question from homework yesterday?
Yeah, from the textbook.
Do you have the exact question?
Yeah. So for number 15, it says that Dimitri has let out 4 meters of his kite string, which makes an angle of 72 degrees with the horizontal ground.
So here's the ground. Here's the kite.
23? What's the question? 23, sorry.
15.
That's an ugly looking kite.
Oh, yeah.
So where's Dimitri?
He's 40 meters to the side.
So we're over here.
Yeah. He let out 40 meters of the kite string,
So this is 40 meters.
and then it made an angle of 72 degrees.
So that was 72 degrees.
Yeah. And then that's just, they made it like a right angle, so we made it like a triangle. It says find the height of the kite to the nearest meter. So like I assumed that, like I used the sine of theta, and I did opposite over hypotenuse. And so I knew that theta was 72 degrees, and the hypotenuse
Oops. Quote.
was 72 degrees.
Sine of 72 is equal to.
And then opposite over 40 meters, or 40. But how do you what do you do after that? Do you isolate? Like, how do you isolate O?
You leave O. Oh, I know. You can always move the denominator.
Well,
That's what
let me ask you this: if this was 10 is equal to O over 40, how do I isolate O?
Multiply each side by 40.
Yes.
But then, how do you multiply?
When you do sums.
Sorry, I was tired. I was doing something.
No, you know what? It's a good question. And a lot of there's some confusion thinking, what sine is 72? It is just a number. It's a ratio. That's why when you hit 72 sine in your calculator, it pops up this huge decimal. Right? It's just a number. So treat it as such. Okay? You don't have to calculate sine of 72 to the very end. You go 70 times sine of 70. It's just a number.
What if you want to? Like, can you?
You can, you could lose position. I would just always suggest that isolate for your variable with your sine, cosine, tan, whatever, and then do all your calculations at once. Okay? Because that way you will get better precision. You get much more accurate answer. Yes, Trey.
I was just wondering, what if the number was on top and the variable was on the bottom? How do you solve that? Like if 40 was on top and O was
How do you solve for that?
You know what when it's like with
I'm asking you, how do you solve for that?
you times it by O and you get 10 from it. And then you divide it by 10 on both sides.
So instead of 10, I'm just having sine of 72.
So it just becomes sine 72.
I'm just saying treat sine of 72 is just a number. So here it would be O is equal to 40 divided by sine of 72. It's just a number. Okay, it's just a number. That's why that whole exercise, that first question, where you guys were figuring out the theta and everything, all it was just asking you for just that fraction. That's what tan, sine, and cosine. It's just a fraction. It's just a number. That's all good.
Do we have more concepts to learn?
This is it.
Just getting a lot.
Seriously?
Well, hopefully, by doing your homework last class, there was a whack of questions, right?
I did.
So somebody else raise their hand? Jake?
Is there going to be special right triangles?
Nope. That's why you weren't tested on this either.
So basically everything on here plus this here.
Plus what I'm doing right now, which is just really applying what we know.
Will there be like a lot of one columns?
Unless you don't want to write it.
Oh.
And I'll let you know when I give it to you on the day of the test. I don't know why do you guys think that if you keep asking me what's gonna be on the test that one day I'm just gonna buckle under and say, you know what? Here it is! Here it is! You know what?
All teachers do like, oh, like hint, this is a good question.
Yeah, they're always like,
Hint,
this
hint.
is on the test.
Hint, hint.
So this might be on there.
It's gonna be signed on the test, okay?
Oh, thank you.
Oh,
Are there gonna be numbers?
No, no numbers though.
Okay.
But lots of words because words confuse you guys.
Makes sense.
So you're gonna write all the numbers out as words.
That's
Okay.
I guarantee.
Okay, so notebooks, we need to go through a couple of definitions so that you can do word problems more effectively as we talk about them. Hint, hint! You need to know the angle of depression, which is why I put a star asterisk there.
Thank you.
Be a good hint for you to take out your notebook and write it down.
Oh.
Pardon? So really the last thing we need to talk about is solving problems involving right angle triangles.
Word problem.
Will there be word problems on the test? You have to.
I just asked that.
That's the format. That's
No, there will be solving problems involving right angle triangles.
word problem. Well,
That
there's
is a
word
word
That
problem.
is a word problem.
That's a word problem. Then you could just say that there's a word problem.
Does not every single question in math have a word in it?
No,
Solve!
a word
Solve.
is different than a word
Solve
problem.
for
A multiple word problem. A word heavy problem.
Exactly.
angle of
With
depression.
a scenario involved, like a real life.
Angle of depression, also known as angle of declination, is the angle measured below the horizontal.
Your diagram is
Okay, conversely, the angle of elevation, also known as the angle of inclination, is the angle measured above the horizontal. Okay, so here's a diagram to sort of illustrate the difference between the two. So when we think of angle of depression, I mean depression is usually meaning like down. Like if you're depressed, you're feeling down, right? There was a depression that happened in the 50s because everything went crashing down. So I think of depression, it's like looking down. So we usually implied is that something's up high, so this could be like a building, right? We're standing on top of the building and we're looking down. So it's almost like the angle I need to tilt my head to go down, or the angle that has to come off the building to hit the ground at a certain rate. So this is what we talk about the angle of depression, right? So it's almost like if I'm up high and I get a line that's horizontal, parallel to the ground, straight from my eyes or from my feet, straight out, right? And then the angle down from that, that's the angle of depression.
The horizontal, this horizontal is the same as the bottom one, the both angles of elevation. So it's
The big thing, yeah. Good observation. So on the opposite, elevation usually implies that we're looking up. Something's going up. So here, it's lower. We're referencing something that's higher up. So over here, this is the angle of elevation. And as Demetrius just pointed out to me, based on our angle theorem, we see that the angle of depression really equals the angle of elevation. Okay, Adrian?
The angle of depression equals the angle of elevation.
Well, see, yeah, you see that,
Oh, yeah.
right? Because of that Z or opposite angle theorem. Okay, and actually we could write that down. Equals angle of elevation. Pretty good diagram, Daryl. Thank you. Trying to look for the triangle though. Yeah. Everybody done with the diagram? Good now, Robbie?
Yeah.
So let's look at a problem. Supposed to be Superman. I can't write this. So I believe it's Lauren. Lauren and Lois are facing each other. So write this down. Right? So the nice thing about to me is writing down the actual problem is you can start thinking about it. as you're writing it down. What do these words actually mean? They must have some meaning.
That's a word problem, so there will be word problems on
Yes, Mom.
the
Please help us. Here.
It's like,
Sorry, I don't thank you.
do you not have your glasses?
Always
You need to bring the markers.
I know, I'm just one forgetting.
I got my
It's
glasses.
hard for me to enlarge this. So I'm gonna read it.
The word called art.
Lauren and Lois
Said that, you have to lie.
Why is it actually?
are facing each other on opposite sides of a 10-meter flagpole. From Lauren's point of view, the top of the flagpole is at an angle of elevation of 50 degrees. From Lois's point of view, it is 35 degrees. How far apart are Lauren and Lois? So how do we begin to answer this? Audrey, draw a picture. Good. So what's the first thing we want to draw, baby? No, I'm not going to draw any triangles.
The flagpole.
The ground? Sure, let's draw the ground.
Which way is the flag on the flagpole? Or does it have no flag?
Good. Well, we don't even know it has a flag. But,
So then how's that anchor?
well, the flagpole usually goes, what, from the ground? Straight up.
The light post.
I'm confused on how, like, when it says 50 degrees and 35 degrees.
It says from Lauren's point of view. So we're talking about a flagpole. So just drawing the flagpole. Right?
Oh.
Lois and Lauren, I should draw.
Yeah, so let's draw Lois and Lauren. Where are they?
Standing on the ground.
They're standing. But where are they relative to each other in the flagpole?
Oh, one's close, Lauren is going close.
No,
Lauren's farther away.
Well, you know what? How far close? Okay, we're not looking
I mean, she's
for
close.
like an accurate, like completely
Lauren
100%
is,
accurate picture, but just something that gives us a representation.
Lauren's dark.
Lauren's the angle of elevation.
Lauren is closer to the pole and Lois
But where
is farther
she is,
away.
the angle of elevation is 50.
Okay, but where is she relative to Lois though?
Opposite
No,
side.
thank you. So opposite sides, right? They're on opposite sides of the flagpole. So let's draw Lauren over here. She have long hair, I guess. I don't know. Lois could be over here.
No hair.
No, she had curly hair or something. I don't know. Maybe she has a beehive. She's from the 60s or something. I don't know. Okay? So this is Lauren and Lois. The point is, they're on opposite sides of the flag, but one's on one side, the other's on the other. Right? Well, what else do we know about the flagpole though?
It's gonna be
It's 10 meters long, so we're just going to put that here. Right? 10 meters high. So now it talks about Lauren. So who's Lauren?
Wait, which one's yours?
I don't know.
It's the one on the left.
Lois is on with the beehive.
Sure.
Yeah.
Let's do Lauren. Lauren's here. Lois is here. Okay? See, math can be fun. It's really fun.
If we get there.
So nervous.
So Lauren, what are we talking about the flagpole here, Lauren?
From her view, the angle of elevation is
Yeah, so from where she is, and usually with these questions you're talking about from the ground. Okay, well for sure where she's standing. So from here to the flagpole, to the top of the flagpole, we're saying that this angle of elevation again was the angle going up. So it's this angle here.
How did you know she's
We just tell you, okay? You just be thankful that we tell you. We'll ask you to measure it. It's 50 degrees. What else? Are we starting to see something here now? Yeah, we're starting to see a triangle. What's this triangle? We're assuming that the flagpole. These are the things that we shouldn't have to say in the word problem, like, oh, the flagpole is 90 degrees. We wanted you to think for that for yourself, right? Usually the flagpole is sticking straight on the ground. It's going to be 90
But
degrees.
you always say never assume numbers, you have to prove it.
I remember that when you when I mark your exam.
Like, what if there's a hurricane with black holes like that?
Yeah, exactly.
It could be 49.99.
So, that's what we know about Lauren.
I mean,
What about Lois?
We're level
35 degrees.
Yeah.
So here is 35. What are we asked to calculate?
How far distance between
How far apart they are. So that's this thing over here. That's what we want to calculate. Well, how can we get that though? Yes, Audrey.
Can't you, okay, well, first of all, you have to look at it as a big triangle, and then you have 50 and 35, and you know that the inside of the triangle is 180, so you can take 180, add 50 and 35. So that will give you the complete angle of the top. Yes.
This one here?
And then once you find that, then you can.
Okay, well, first of all, what is that there? So it's 50, that's 95.
So you have 95 degrees, and then you can extend the lines further, and then find which one. Continue extending them and find which one.
So extending this like that, like that? Okay.
Wait, why are you
On
extending
like on every single one, every line.
On every line. So
Yeah.
extending here as well.
Yeah.
Um,
No? Do you agree?
Okay.
And then, yeah, no idea.
Okay. That's fine, no. Good try. So we're not trying to get similar triangles here because there's only one triangle. Well, actually, there's two triangles, but they're for sure we know they're not even similar because this one's 50. Well, if this one's 50, what's this one have to be up here? This one's actually 40 up here. They don't have the same angles. So you know this has nothing to do with similar triangles.
Since you know it's 10 meters, then can't you look at the 50 degrees and you do opposite?
Yeah. So what we recognize is that here, this distance is the same as if I label this as x. If I label this part as y, this distance is x plus y. Right? So how can I calculate for x? So how can I calculate for x? Do you see this, Audrey? That we have a right angle triangle right here.
That's the correct answer, Bob.
We have another one over here. Okay? So basically we're working with two right angle triangles, but we know that the sum of these two lengths, basically the distance from the flagpole to Lauren plus the distance from the flagpole to Lois, gives us the distance from Lauren to Lois. So how can we calculate for x?
So do the opposite over. Would it be adjacent?
Well, yeah, well we're given 50. What else we're given?
10.
10, which is what relative to 50? What side? The opposite.
And then adjacent to x.
Yeah. So here we got 10. Well, I just told you the answer. Actually, what's the relationship with an angle, opposite, and adjacent?
Yeah, 20.
It's 10, right? So we got 10. A theta is opposite over adjacent.
What?
So theta is what in this case?
Wait. What is
Theta is
under
the
10?
50. The log is the 40.
Is that adjacent?
Oh no, it's 50.
This is it's the opposite.
Oh.
Oh, 2 theta is
So yeah, theta is 50.
and then How do you know?
Opposite is 10, and the adjacent side is x. So x is really 10 over tan of 50. Which is, so take out calculators. What's 10 divided by tan of 50? Adrian? 8.39? Same answer as my last class, so that's good. Right, so here we see that this distance is 8.39. So to calculate y, what are we looking at? Well here, what's this side to this triangle? What is it still? It's also still the opposite. And y is relative to this angle, adjacent. So we're not doing anything with this hypotenuse, which is a good thing because we don't know the length of that.
The tangent.
So yeah, we have another tan of theta is opposite over adjacent. You guys realize that I'm not writing this for my benefit. I want you to practice what I'm writing down so that when you get to the test, you do your questions, you're doing the same thing. This is the start to you thinking, believe it or not. Okay? So tan of theta, here what's theta?
35.
35.
No.
So opposite is 10 over y. Good. So y is equal to 10 over tan of 35. So what's y?
What?
10 divided by tan of 35? Sorry? 14.28. So therefore x plus y is equal to 8.39 plus 14.28, which is roughly 22.67.
Yeah.
So therefore,
Yeah, I got that.
Lois and Lauren are 22.67 meters apart. Okay? So the hard part really was drawing that diagram. Just seeing where's Lauren, where's Lois, what are we talking about? So all I'm saying is I appreciate you guys saying that, yeah, the words are confusing, all there. That's why it's important to draw a diagram. Math or worse is something visual that we can see. Okay, Adrian?
Do you just have to assume that we have to round to 2 decimals?
Yeah, it's round to 2 for now. Right? I mean, I'm going to be lenient on the rounding if we don't specify. Okay? But by default, 2 decimal places. Yes? No, because there you can have it radical.
You want to have it.
Yes, if I give you 2 sides, you do a square root of something.
Oh, is that why you basically this?
Talk about it. I'll talk about that after, okay? Any other questions on this? One last example. So there are some questions that are.
So shy.
No, I don't think you do practice. You just have to do the.
You have to do it in practice.
You just have to. You can't do the practice part of the company. You have to divide.
I think I can.
Divided by 35 can.
There we go.
Equals.
10.
You just equal 2 times?
7.
No, you did. When you hit 10, they give you the 10 in that number. Yeah, do equals.
Like always.
Here or after?
Okay. The recordings? Did I not show you guys how to access that last class?
Yeah.
You go to cloud 2.
Oh, our class.
All the classes. Okay.
I thought yesterday was Friday.
So in some of the word problems, there's questions sort of like this. I want to make sure we go over one because some of the terminology and some of the how you set it up is kind of weird.
Oh, the plain one in the homework.
So write down the question: scuba divers swam north
Do the homework.
at 1.5 meters per second across a current running east to west at 2.0 meters per second. Across a current running from east to west at 2.0 meters per second. She swam for 3 minutes and then surfaced.
She underwater?
Well, scuba diver, she got scuba gear on.
Oh, okay, yeah.
Yeah, don't be that impressed with it.
Say good.
So A, draw a diagram showing where she surfaced relative to where she dove. So we have questions that deal with directions. First thing I do is, even before drawing the diagram, is I orient myself. So here, I usually have north going up, south going down, then east would be going to the right, and west would be on the left. Okay, so just orient yourself. So here what happens, she's swimming north. So let's say that she's swimming north at 1.5 meters per second. So if there's no current, she would just go straight north. Problem is there's a current that's going from east to west, so right to left, that's going like this. It's sort of pushing her this way. So if she would have started here, she would have been pushed from left to right if she didn't do anything. She would have been pushed at a rate of 2 meters per second. But she's also trying to swim up, so really her net direction is going to look something like that. So if she started here, she will wind up somewhere over here.
Wait, why'd you add that extra line? Like just leave it?
This last one?
Yeah.
Because it's showing like the direction that she would be actually traveling. So you have
Oh, okay.
you have your river going this way, but she's trying to move up this way. So the net effect of that is, so if I had it like this, she's trying to swim this way, but she's being pushed. So that's how she kind of looks. So she would have went sort of like in this way. So roughly that's what she would have
So she
wound up.
wanted, from that black dot, she wanted to go up?
Yes. So this black dot, she wanted to go straight up, really,
But the
but she's
current
being
pushed
pushed.
Is the first line you drew, it's like curved at the top. Is that supposed to happen?
First, it's supposed to be an arrowhead.
You wrote it like that.
It's not supposed to be.
I tried to draw it randomly like that. This smartboard is kind
I think the whiteboard is much easier.
of. Well, the one in Mr. Dolma's room is way better. Okay, so the question is, how far did she actually travel? So how far did she actually travel? So given that she started here, wound up over here, if she wasn't swimming at all, how far would she travel this way?
2 meters.
2 meters per second, but how long was she swimming for?
So, 180.
So 3 minutes,
So 180.
is really 180 seconds, right? So if the current is moving at 2 meters per second, how far is this then? Well, 2 meters per second times 180 seconds gives us 360 meters. right? So she just stood in the water or just floated in the water. After 3 minutes, she would have moved 360 meters this way. But she wasn't just floating there, she was trying to swim. So if there was no current and she swam due north, how far would she get? Which is this part.
It's a very
One-
difficult.
270? How'd you get 270?
1.5 times.
Yeah. So she's traveling at 1.5 meters per second for 300 seconds. Oh, so 180 seconds. Okay? That gives us 270 meters. So basically, we want to find out this distance. Can we assume that that's a right angle triangle, Mo?
Well, you
Does
said
north
not
and
to.
south, does north and south meet east and west at a 90-degree angle?
Yes.
Thank you.
So can we use base curve?
Yes. So this is where,
Because it's a right angle.
because it's a right angle triangle, we give it two sides, we need to figure out the third side. So here's the thing that you guys, I sense, are struggling with. As soon as I teach you something, everything else goes out the window. I was thinking, oh, where's the angle? Tan, cosine, sine. We don't need angles here. Go back to, well, this is just a squared plus b squared plus c squared, Pythagorean theorem. Right? You're given weapons. Choose the proper weapon. Maybe that's the best terminology to use. Tools. Given tools. A lot of you guys play sports. Dan, you play basketball, right? Sometimes you gotta know when to dribble, when to pass, when to shoot, when to drive. You have all these tools, but given the situation, what do we do? What tool do we use? So here, to figure this out, we just use the square root of 270 squared plus 360 squared. And that equals, Laura?
450. But I hope I finished.
Okay. So basically, she's 140, 50 meters away. Yes, Laura?
What if you could just not, not multiply it times for 3 minutes? Just leave it as like 2 and 1.5, and then find it later, so you can not deal with it.
So another way you could, another way you could do it is if you treat this as velocity. What's this velocity over here? It's really 2 squared, 1.5 squared, which you get
2.5.
So this was 2.5 meters per second. You still need to take that multiplied by,
Yeah.
and you get the same answer. So yes, that's what I was doing here. Quite frankly, I'm not a fan of these questions, but what they do try to scaffold you for is if you eventually take calculus, this is all about vectors and forces. You do vectors and forces the same way.
How'd you get the 2.5 meters?
Well, what Nora was saying is if I do 2 meters here per second, 1.5, if I do 2 squared plus 1.5 squared, add together, take the square root of that, I get 2. So basically he's used this triangle and figure out the third side for his velocity.
You don't have
You don't
Could
need
you do it that way?
to find.
And then he multiplied this by 180 to get 450.
Could you do that?
Either way, either solution is acceptable. So did I answer your question, Katie?
Yeah.
Yes, Dan.
How do we move this, like this five, this kind of thing you have? 270 squared plus 360 squared.
Yeah, so that's equal to 450. If I punch in my calculator 270 squared plus 360 squared, I took the square root of that, and we get 450. That's the exact, it works out to be exactly 450. Yeah, good point. This one worked out to be exactly 450. If the square root did not exactly work out, do I want a decimal answer here? No, right? I want the simplest radical. Okay, any questions on this? Any questions on this? This for homework?
I love this challenge option.
Hold
It's
on.
not an option.
What?
Do your homework. If you want to do more, you can do the challenge.
So then,
Hey,